is being recorded, and we will place the recording on our YouTube channel. So if you don't want to get recorded, you may want to drop. Thank you. Prithvi, go ahead.
Okay. Hey guys, this is Prithvi Reddy. I'm a cloud solutions architect here in the South region for Microsoft, teammate of Naveed's. So today we're going to talk about Fluentd. And basically the agenda is we're going to talk about what problems does Fluentd solve, how Fluentd solves those problems, and then the demo. I'm actually going to have to do it on a follow-up call. I had a little bit of a network issue, but we'll at least I'll share the links after the session. So is everybody able to hear me okay and see my screen?
Yes, sir.
Okay. So let's start with the problem statement, and this is at least the clients that I've been working with. There's been a trend for needing real-time logging. So as you know, within Kubernetes, your containers they stream data from standard error and standard out. And one of the big requirements was they wanted to be able to get those standard out messages and store them in EventHub. So and the customers want that real time, that logging real time, so that they can alert on it and make decisions. So a lot of folks who are in the data analytics space, they need to make updates to data models based on these events, right? So one of the challenges with the native capabilities within Azure is that there is latency when you're sending the events to log analytics. So if you read our Azure documentation, the typical latency is anywhere from 2 to 5 minutes for the log data to appear in log analytics. But if you're a data modeler and you're making real-time decisions, that's too long, right? So also the other thing is that once it gets to log analytics, you also have to write what's called an Azure function or an action, and you have to define an action group that takes those alerts out of log analytics and moves them over to EventHub. So just quick recap of a couple of the problems are the latency is too high for real-time logging, and it requires an Azure function with the built-in technology that we have today with log analytics. So how do we solve this problem? So before we can solve the problem, let's just talk about Kubernetes logging architecture in general. So every Docker container that you have in Kubernetes, they write logs to standard out and standard error, and they're referred to as standard out and standard error streams. There's a typo there, sorry. So Docker redirects those streams to a logging driver to write. So basically, it takes that data and puts it in a JSON format. And then, if you're familiar with Kubernetes, you can view those log files using a kubectl command. So kubectl logs, and then you can see that JSON formatted file. But the problem here is that if a pod gets deleted, you lose all of those logs, right? And then the same thing, if you lose a node on AKS, you lose those logs. So this is a pretty common problem in the industry. And so what you need is a shipping container or a logging shipper, which is separate, which has separate storage, it has a separate life cycle that's independent of the pods and the nodes. So even if your pod gets destroyed, your node gets destroyed, you're shipping those logs off, right? So there's 3 ways to do this in Kubernetes. One is, the first method is using a sidecar. So essentially, a sidecar means that every pod has another container running alongside that pod that's capturing the logging data. The second way is node level logging, which is a little bit better. It means that there's a logging container sitting on every Kubernetes node that's grabbing logs from all the pods on that node. And then the third way is to send those logs directly from the application to some backend, which is something like Azure Monitor or Log Analytics. But we'll just go through these 3 approaches real quick and just talk through the pros and cons of each. So we'll start with Sidecar, right? So Sidecar is the most famous one that that folks use for logging. So it's watching for, so over here, you've got your pod, you've got your container, and it's watching for log files and standard error, standard out, coming out of that pod. And this sidecar, which is a logging agent pod, is sitting there, and it's going to take these logs and going to send them off to a backend, right? But the problem with this approach is it doesn't scale very well, because for every pod that you have to deploy a sidecar for it, right? And but the advantage of using sidecars is that you can read logs from the pod that don't support standard out and standard error. There are some apps, legacy apps, that, you know, if you're over 30 years old, you probably know, like from your early Linux days, that a lot of things got sent to var log messages and things like that, right? And those legacy apps, that's the only way. You have to read that log file to get the data. But now, like modern apps, they send directly to standard out and standard error. So just keep that in mind. It's one of the benefits of Sidecar, is that you can read those logs. But as I mentioned, Sidecar is not very scalable, right? So this is where node level logging really comes into place. So each of these pods, like pod number 1 has an app container, pod number 2 has an app container, and each of them is writing standard out, standard error. This is how modern programming languages are working today. Rather than having a sidecar for each of these pods, in Kubernetes, there's a concept called a Kubernetes DaemonSet. So with the DaemonSet controller it's a node. Each node think of this as node 1, and think of this as node 2. Each node is going to have a logging agent, and the logging agent will then send it over to, in this case, we're going to talk about Fluentd. So those logs are going to be aggregated into Fluentd, and then Fluentd can be sent to any output plugin. So Fluentd has 2 key components that are important. It has an input plugin where you can filter what logs you want to send to the aggregator, and it has an output plugin where you can specify where you want to send the data to. So as a quick recap again, this node level logging is only for standard output, standard error. So a lot of the folks who are fresh out of college, you're very familiar with this. So any questions there? Difference between sidecar and node level, and why node level scales better for an enterprise? Okay, so I'll keep moving on. I know this is some of this is very wordy, but so just a quick recap. Node level logging is preferred because you can centralize all your logs from multiple apps to a single node, and then Fluent is deployed as a daemon set in the Kubernetes cluster. And why did we pick Fluent, and why are we focusing on Fluentd today? So Fluentd is an open source product. It's actually part of Cloud Native Foundations. It's very popular because it supports all the outputs that you know of, like Apache, Python. They have plugins for all the network protocols. And last but not least, we have support for a lot of the Azure cloud APIs, like Azure EventHub, Azure Data Lake Storage, and more. In addition to this, a lot of my clients ask for, hey, not only do I want to send it to Azure endpoints, the output of my logs, but I also want to send it to things like Elasticsearch, Splunk, Hadoop, Kafka, Datadog. These are very common in the industry, and Fluentd has output plugins, so you can send it to any of these destinations as well. Any questions? Okay. So this is just a quick overview of what's Fluentd. So it allows you to divide and conquer. So these Fluentd processes right here are collecting from different sources. So you could have any number of Fluentd plugins, one that's collecting applications, one that's collecting log files, another one that's doing HTTP. Each of these red boxes here represents a different input plugin. All those input plugins will go to a Fluentd aggregator. That's what this middle box represents. The nice thing about this is even though it's open source, it automatically has a divide and conquer. So it splits the load, it routes those messages. If the message didn't reach properly, it retries. So it also has something very interesting for parallelism. So you can run more than one. So if you're running, this is running in a container, right? And if you're running in a multi-core container, these processes can be spawned in parallel, and you can specify all that in your flush options. Then you have these plugins, as I mentioned earlier. So these plugins are written in C and Ruby. So if you guys are C and Ruby programmers, you know that these programming languages are very lightweight. So they allow you to read the data, parse the data, and you can format them as well. So again, a little bit of review. Fluentd is open source, and as we mentioned earlier, everything that comes out of Kubernetes from a logging perspective gets stored in a JSON format such as this. So what Fluentd is essentially doing is taking this JSON formatted file, and the input plugin, you specify where you want to forward this to, what you want to do from a formatting perspective. The engine is going to run, it's going to buffer it, and then it's going to write the log out to an output. So the output could be anything from MongoDB, a file, or EventHub. Any other questions? So I'm going to go through, I had a demo, I did have a little bit of a snag, but I'll just go through a quick link, and I'll share the links after the meeting.
Hey, quick question here. How different
Sure.
is this from using application insights?
So the application insights is integrated with Azure Monitor, and as we mentioned earlier, that depends on log analytics. Let me just jump back to that slide. So the whole reason why we're going down this route is for real-time logging. So the use case here is for real-time logging. When you use something like application insights, it goes to log analytics, and there is a latency to get those events into log analytics. It's up to 2 to 5 minutes. So if you're okay with that kind of latency, then application insights is perfect for your use case, right? This use case with Fluentd is really for real-time logging, where an event hits your container or your app pod, and you need to be able to react to it right away. So it's great for things that people who are doing things like data modeling, those type of use cases. Does that answer your question?
Sure, yeah.
Okay. So let me do this real quick. So typically when you, as I mentioned, a DaemonSet is what gets deployed on all of your nodes on your cluster. So if you go to the GitHub link for Fluentd, they have samples for the DaemonSet. So DaemonSet is nothing but a pod that runs on every node. And so you will specify how much memory, how much CPU that Fluentd aggregator is going to have. And this is the key piece right here. So as I mentioned earlier, output plugins. There's an output plugin for Fluentd event hubs that you can specify. The other key piece is that we have something called a match file. So if you go to GitHub, and I'll paste the link here so you can look at the Fluent plugin in the chat. But this is the main piece of the configuration. So when you configure an Azure Event Hubs in the Azure portal, so there are key pieces of information that Fluentd needs to know about to be able to write to that Event Hub. So it needs the connection string. So the connection string you get directly from as a SAS string from the Azure Management Portal, the name of the Event Hub, and then here's where you specify all the tags that you want, the expiry. If you have proxies involved, you specify any proxies, and then whether you want to batch, we want to batch up all of the events, or you want to send them all a message per record. Now, one interesting thing that we ran into when I was working with one of my customers is if you do a search for Fluentd flush options. The one of the things that Fluentd does is it, as I mentioned, there's buffering and retrying parameters within Fluentd. So if you use the default flush method, it's referred to as lazy. So it doesn't immediately send the data onto your output plugin. So this is very important, is to set the flush mode to immediate so that it flushes all the data out of the aggregator and sends it on to your output plugin. I was planning to do a demo. I did run into a little bit of an issue when I was rebuilding it for EventHubs. But essentially, all the documentation is online. You have to get the DaemonSet, as I mentioned earlier, and then deploy your match file for what you want to actually filter and send over to your output plugin. Any questions, concerns? I know we have 10 minutes, and it's a little bit early end to the call, but
yeah, Prithvi, I have a question. Can this solution be used to implement event-driven architectures, especially when it's being sent to EventHub?
yes. So this solution, so all the logs that you're getting out of your Kubernetes pods are being sent. Those events are going to be streamed real time to Azure Event Hubs. And it doesn't necessarily have to be Event Hubs. It can also be Kafka or any of the other plugins that are available via Fluentd.
Service bus.
Service bus. Azure Data Lake is another use case that we get from a lot of customers. So, and if you look, there's a whole marketplace of Fluentd plugins. So we even have ones for MS SQL and more. Azure Storage, Event Hubs, and MS SQL are the big ones that we've been seeing, but there is a full list online of the output plugins. So if you just do a search for Fluentd output plugins, Azure, you'll see a list of all the plugins, and you'll be pleasantly surprised on the number of plugins that are there. Or you can do all of them. Does that answer your question?
Yes.
But once you get your logs, your events into EventHub, then you can create a monitoring strategy off of that, right? Hey, based on this event, I want to write an Azure function that goes and takes action on that event.
Or they could be subscribers that are listening to that, who are interested in that event and can act upon it.
Correct. Yep.
Got it.
And
Thanks.
so this solution is really for those real-time use cases that you have out there. So
you mentioned that Fluentd has plugins. You mentioned Fluentd has plugins to send data to different places. I mean, if you are sending it to EventHub, can you use EventHub then and other things to subscribe to that? I mean, is that possible as well?
Yes. So once the data is in EventHub, yes, you could subscribe to those events.
Okay.
So that's
how about
it.
setting? Oh, sorry.
Oh,
How about setting? Are you able to set buffers on how much to flush and how often, or is there any other caching mechanism built in?
Yes, there are mechanisms for that. They have configurations for how much is in memory or in your working set, as opposed to how much is going to disk. So that there is a whole performance tuning doc for Fluentd, which I can put in the links when the spec gets sent out. But yes,
Awesome.
it gives you a lot of flexibility on your buffers and your caching. It's actually a very powerful tool, Fluentd. There's also an equivalent. There's also Fluentbit, but Fluentd is mainly the one I've used. So Fluentd actually is a log processor and forwarder, and Fluentd is the aggregator. So you can use both in conjunction with each other. So Fluentd allows you to do a lot of your parsing and filtering. And then once you've parsed and filtered, let's say you don't like it in the JSON format, or you want to reformat your logs into a different format, you can use Fluentd to do that, and then send that on to Fluentd, which is your aggregator. And I apologize, I was supposed to do a demo of this. I probably I can put it on. I ran into a little bit of a snag when I was testing with private endpoints, but I guess that's a good segue. So in previous sessions, we talked about private AKS clusters. EventHub also supports private endpoints now. So this traffic will be completely private. So it's a private AKS cluster talking to a private EventHub. And you just have to make sure all your routing and DNS is correct between AKS and EventHub.
So basically, you can, I mean, make everything private, so there is no internet. I mean, no public internet jump.
Correct. Yep. Everything stays private within your network.
Okay. Cool. Yeah. If you can, do you have those links in that slide deck? By the way, we'll upload the slide deck as well with the video. So those links are there, then people can take a look at it.
Sounds good. Yep. And I'll be publishing a GitHub page. I ran into one little error on the events this morning, so I couldn't show you the demo, but I will publish it in the GitHub, and you guys can feel free to use that.
So folks, any other questions, comments, feedback? Okay. Prithvi, thank you. Thank you very much. Thanks everyone for joining, and I hope to see everyone next week for another session of Azure Power Lunch. So thanks, Prithvi, and have a great weekend, everyone.
Thanks.